So for this worksheet, we are going to calculate the pH of strong monoprotic arrhenius acids and bases. So this is a pretty loaded phrase here, so we have to kind of dissect each one. Strong means that the acid or base will dissociate 100%. Monoprotic means there's only going to be one H plus or one hydroxide, as opposed to something like H2SO4, there would be two acidic hydrogens, or barium hydroxide, there will be two hydroxides. And so monoprotic means just one of them. Protic, referring to protons, also means hydroxide ions in this context. There's only going to be one of those as opposed to two or three or more than one. Arrhenius acids and bases, that means H pluses and OH minuses. And so that's what we're going to be focusing on, specifically hydrochloric acid and sodium hydroxide. So we need a list of equations to work with, and then we'll do a couple of the rows. The first reaction we need to deal with is what happens in aqueous solutions, and that's water dissociates into H plus and OH minus. So this happens by itself. It happens without any other chemical involvement other than water. At 25 degrees Celsius, we get a K expression, Kw, W for water. Products over reactants, or two products, are H plus and OH minus. Water is a liquid, so that doesn't go into the expression, and this value is 1 times 10 to the negative 14th. So no matter what we do, whether in terms of adding acid or base, this product will always equal 1 times 10 to the negative 14th. And so these two columns here will multiply up to 1 times 10 to the negative 14th. So if I have one, I can solve for the other just by using this equation here. Now, P in pH stands for negative log. That actually stands for power, but mathematically negative log. Using our log rules, we can go from this equation to this one. When you take the negative log of two things that are being multiplied, you end up adding them. So you end up with pH plus POH equals 14. P stands for power, so what it really focuses on is the exponent. P stands for negative log, and so the negative goes away and the exponent becomes the number. So pH plus POH equals 14. That means these two columns add up to 14. So if you have one, you can solve for the other. The bigger issue is how to go from, the next issue is how to go from OH to POH, or POH to OH. And so we'll set up another column of equations. pH equals POH equals, P stands for negative log, H stands for the H, and OH stands for the OH. And so if I have the hydrogen, then I can calculate pH by typing in negative log into my calculator. Now the opposite, what's the opposite of multiplication? You say division. What is the opposite of addition? You would say subtraction. What is the opposite of a log? That's a good question, because that's how we have to get the H plus and the OH minus. H plus equals OH minus equals. So the opposite of a log is what I call the antilog. In your calculator, it's written as 10 raised to the power of negative pH. These logs are base 10, and so the opposite of that is you raise something from the 10th. You raise 10 to the negative pH. 10 raised to the negative POH. I tend to call this anti-log. You can say to the 10th power, the 10th to the pH power, 10 to the X power, whatever phrasing you are comfortable with. Like I said, I generally call it the anti-log. With these equations, that allows me to go from pH to H+, or POH to OH. So using these 6 bulleted equations, we can solve for the rest of these. So I'm going to scroll down just a bit, and we'll do the first 2 rows together in a different color, of course. Recognize your acids. It's good to know your strong acids and strong bases. This is a strong acid. What that means is that the hydrogen from the hydrochloric acid is going to 100% become the H+. You can write down the fact that it's an acid. So the 0.1 molar hydrochloric acid will dissociate completely to give me an H+ and a Cl-. 1-to-1, 100%. You can do stoic for it, but it'll just be elongated. It's very simple to say that the concentration of the monoprotic strong acid is equal to the concentration of the H+. The hydrochloric acid is going to dissociate 100% into the H. 1-to-1 exactly. And so now you can keep going forward to do some math. Thanks to this equation here, H times OH equals 1 times 10 to the negative 14th. I know that the product of these two would be 1 times 10 to the negative 14th, and so KW equals H plus OH 1 times 10 to the negative 14th. The H concentration is 0.10. The hydroxide concentration is X, and so I can solve for that and get 1 times 10, 1.0 times 10 to the negative 13. And now to get the pH, I'm going to need to take the log. Take the negative log, excuse me. And so negative log of the H+, that's going to give me negative log of 0.1 would be 1. 2 sig figs for pH technically has 2 decimal places. That's because the 1 is an exponent, comes from the exponent of negative 1, which is not a number that needs significant figures for. The 1, 0 is 2 sig figs, so it's 0, 0. Just new sig fig rule for logs. Here we have log of OH. So again, that focuses on this, and that gives me 13.00. So the 13 comes from the exponent, which is not a significant number, but the 00 comes from the 1.0. And so that's how to do it, starting with strong acids. Starting with strong bases would be much of the same way. Recognize the fact that this is a base, that is a strong base. So that means that all of this sodium hydroxide will dissociate, so we can write that down up here. Dissociate to sodium and hydroxide. 1-to-1 because of the balancing, and so concentration for concentration. Because all of this sodium hydroxide will generate equal moles of the hydroxide anion. Again, to go from OH to H, you can use this equation here that the product multiplies up to 1 times 10 to the negative 14th. Solve for, in this case, the H+, and you end up with 1 times 10 to the negative 13th. For sig fig's sake, it would be 1.0 times 10 to the negative 13th molarity. And then to go from H to pH, use the negative log. to go from OH to POH, you would use negative log as well. It looks like 3 sig figs, but it's actually 2 sig figs using your log rules. So that's how you can do it. You do have to put some thought into it, but recognizing that these two columns multiply up to 1 times 10 to the negative 14th, that the product of the OH and the H will multiply up to 1 times 10 to the negative 14th, will help you between these two columns. To help you between these two columns, you realize that their sum is 14. The sum of these two columns add up to 14 based on the log rules of the KW expression. And then you just have to use log and anti-log to work backwards. I want to do one of those with you. The 356 will get me the H plus. So H plus equals the anti-log, or 10 raised to the negative pH power. So you get used to being able to input that into your calculator. You end up with we're looking for 2 sig figs, because only the 3 is not significant, the 5, 6 is. So we end up with 2.8 times 10 to the negative 4th molarity. So that's the anti-log of that. And if I were to take the log of this, the negative log of the 2.8 times 10 to the negative 4th, I should come back to the 356 number. And so feel free to test that out into your calculator if you're uncomfortable with the anti-logs. This way you know you are correct. So there's enough information for all of these blocks. The hydroxide concentration will give me the sodium hydroxide molarity. The H plus concentration will give me the concentration of the HCl. I think that addresses everything. Neutral water will be a nice little thinking type thing. Remember, the neutral water does not mean 0 and 0. It means something else. That doesn't mean there's no acid and no base. It means there's no net acid or no net base, I guess, but they are neutralized each other, but there's equal parts of each. It's not 0, 0, it's not 1, 1. There is a amount that multiplies up to 1 times 10 to the negative 14th. And the pH of something neutral is not 0, 0. There's numbers here that add up to 14, but they will be equal to each other because they are neutral. That's what it means to be neutral. Equal concentration, equal pH and pOH. Enjoy the empty blocks, fill them in with correct answers.